Hello, guys. Uh, let's see if our connection is good. Please, could you please give me a plus in the chat if I can be seen and heard? Thanks, guys. So let me introduce myself. My name is Emil, and I have been working in IT field for over 20 years, and my focus is a computer networking, and so we will have two more tech talks on this topic, but for several years, I have been discovering DevOps and automation, and today I am delighted to welcome all of you to this gathering where we will be delving into the world of infrastructure as code. This is a topic of a great relevance in today's technology landscape, and it's a pleasure to see so many of you here, eager to explore its potential and significance. Today, we will delve into the fundamentals of infrastructure as code, its benefits, challenges, and best practices. So, without further ado, I invite you to open your minds to the possibilities and that infrastructure as code brings to the table. So today I have Mr. Yoda here to help me with my presentation. And today I have another one. Here is another Mr. Yoda who helps me with my studies. He is my study buddy, and he also helped me to prepare for my presentation today. And he took my speech silently and without objections. So thank you for joining us, and let's get started, guys. Okay, so what is the infrastructure as code? Infrastructure as code is the practice of defining and managing infrastructure resources using code. This code can be version controlled, tested, and deployed just like any other software code. Infrastructure as code allows you to automate the process of provisioning and managing infrastructure resources, which can save time and reduce errors. So this means that instead of manually configuring infrastructure like servers, networks, and other infrastructure components, you can use the code to automate the process. So let's see what is the key components of the infrastructure as code. There are several key components and concepts that are important to understand when working with infrastructure. First of all, I need to mention the declarative configuration. Infrastructure as code uses a declarative approach to configuration, which means that you define the desired state of your infrastructure resources. And the system takes care of the details of how to achieve this state. The next one is the desired state configuration. Infrastructure as code emphasizes defining the desired state of your infrastructure rather than scripting the steps to reach that state. Simply saying, by specifying the desired state, the infrastructure as code tool can evaluate the current state of infrastructure and automatically make any necessary changes to bring it in line with the desired state. Next key concept is the idempotency. What is this in the simple words? Um, Infrastructure code should be idempotent. What does it mean? It means that running the same code multiple times should produce the same outcome as running it once. Idempotency ensures that your infrastructure remains consistent regardless of number of times you apply the code. It allows you to safely apply changes without causing unintended side effects. I will show in the demo what does it mean, what how this key concepts works. Next one is the immutable infrastructure. Infrastructure as code promotes the use of immutable infrastructure, which means that infrastructure resources are treated as disposable and are replaced rather than updated. This approach can help to reduce downtime and increase reliability. And the last one is the configuration management. Infrastructure as code often incorporates configuration management to manage the configuration of software and application deployed on infrastructure resources. Configuration management tools help in installing packages, configuring files, managing services, and maintaining consistency across servers and different instances. And infrastructure as code, needless to say that infrastructure as code is becoming increasingly important in modern software development. As applications become more complex and distributed, managing infrastructure resources manually becomes more difficult and error-prone. So infrastructure as code allows you to automate the process of provisioning and managing infrastructure resources, which can save time, reduce errors, and increase reliability. Additionally, infrastructure as code can help to promote collaboration between development and operation teams. This you can see that DevOps, we can use this word for this. We can use the infrastructure as code such as like some of the tools that can we use in DevOps. And so YAC, infrastructure as code, helps you to use these tools, infrastructure as code tools, to manage your infrastructure easily. Let's go further and see another benefits of infrastructure as code. Let's see. What is the benefits? First of all, we could see about the consistency. Infrastructure as code is a process of managing and provisioning computing infrastructure through machine readable definition files, rather than physical hardware configuration or interactive configuration tools. And infrastructure as code provides a way to automate the deployment and management of infrastructure, making it more efficient, reliable, and scalable. And we will see how it works later on our demo. And using infrastructure as code has several benefits. And it includes you can see on the slides, it includes, first of all, consistency. Infrastructure as code ensures that infrastructure is consistent across all environments. In the development infrastructure, we can have several environments from development to production, and this consistency ensures and reduces that the risk of errors and makes it easier to troubleshoot issues. Next one is the reproducibility. Infrastructure as code allows you to reproduce the infrastructure in consistent and repeatable way. This is particularly useful when you need to create multiple environments, such as for testing, as I mentioned before, development and production, and etc. Sorry. Next one is the scalability. Infrastructure as code makes it easier to scale the infrastructure up or down as needed. This is particularly useful in cloud environments where resources can be provisioned on demand. And it's very helpful to use these benefits in your infrastructure. Next one is the version control. Infrastructure as code files can be version controlled. This allows you to track changes and roll back to previous versions if something happened, if you have some issues or any other situations. And next one is the collaboration. Infrastructure as code, you can share all of these files between other team members and collaborate on these files. This makes it easier for teams to work together on infrastructure projects. So you can have several teams that deployed this infrastructure using the shareable files. So let's go further. So what can infrastructure be used for as code? And infrastructure as code can be used to define and manage a wide range of infrastructure components, including virtual machines. So you can use the infrastructure as code, we will see it later, to provision and manage virtual machines, including their configuration, including networking, storage, databases, and etc. Also, infrastructure as code can be used to deploy and manage different containerized applications, including their orchestration and networking. I'm sure that you are heard about the Kubernetes and different cloud providers that used Kubernetes, and you can use infrastructure as code approach to deploy Kubernetes on the cloud providers or even on the bare metal. You can use the infrastructure as code to define and manage network infrastructure, including the firewalls, load balancers, DNSs, and so on and so forth. You also can use the infrastructure as code to provision and manage databases, including their configuration, replication, and backups. It's very easy to do with the infrastructure as code. Um, Security. Infrastructure as code can be used to define and manage different security policies and configurations, including access control, including encryption, including compliance, and etc., and other components, security components. Overall, infrastructure as code is an essential tool for modern infrastructure management, providing a way to automate and streamline the deployment and management of infrastructure components. Let's go further and see which tools we can use with infrastructure as code, like infrastructure as code. So infrastructure as code tools are widely used in modern software development and operations to automate the provisioning, configuration, and management of infrastructure resources. They allow teams to define and manage infrastructure using code, enabling, as I mentioned before, version control, collaboration, and reproducibility. And here is the some popular, you can see on the slide, some popular infrastructure as code tools like Terraform, Ansible, Chief, Puppet, SaltStack, AWS CloudFormation, and number of other infrastructure as code tools. Today we will explore a little bit Terraform. Maybe you have heard about this tool. Oh, I want to ask you if you're used in your practice, if you use this tool, just please give me a plus in the chat and see if how many of you use this tool. While you are posting your pluses, I'll go further and we will see what are the benefits of using Terraform. Okay, some of you used Ansible. Okay, let's see. What are the benefits of using Terraform? So, as I mentioned before, Terraform allows you to define your infrastructure as code. So, which means you can use Terraform to manage all of your infrastructure. This makes it easier to manage and maintain infrastructure over time. Later, we will see how it works. Terraform allows the multi-cloud support. Terraform supports multiple clouds providers, including AWS, Azure, Google Cloud, and many more. Even you can use the Terraform to manage your bare metal infrastructure. And this means that you can use the same tool to manage your infrastructure as code, your infrastructure across multiple cloud providers. What else? Declarative syntax. Terraform uses a declarative syntax, which means you define what you want your infrastructure to look like, and Terraform figures out how to make it happen. And this makes it easier to write and understand your infrastructure code. And it's moreover, this easier it can be easier to read your infrastructure as code files by your team members. You just need to highlight the comments and maybe some documentation. Terraform has a modular architecture. What does it mean? It means you can break your infrastructure code into reusable chunk of modules, and just connect when it's needed. Just connect from the main part of your code. Just connect to these modules, and it helps you to reuse your modules in other projects, even in other projects. Next, Terraform has plan and apply workflows. So what does it mean? This means you can preview the changes. We will see it on demo in a few minutes. That you can preview any changes that Terraform will make to your infrastructure before applying them. This helps you avoid making unintended changes to your infrastructure. We will see later how it works. And also, Terraform has state management. What does it mean? It means that Terraform they keep tracks of the current state of your infrastructure, and it helps make changes to bring it to the desired state. I will also show you how what does it mean and how it looks like in the Terraform. And all of these features and benefits of using Terraform help us to easier manage and maintain your infrastructure over the time, and it helps you to easily maintain your infrastructure. Let's go to our demo. So here we have a task. So task includes create EC2 instance, which is called T2 micro. We use Ubuntu image, and the second condition that EC2 Ubuntu must have incoming access only to TCP/22 port, and it has to have access any outgoing access. So let me reshare my another screen where I have prepared the my terminal and Terraform. So let's just give me a minute, please. Okay. 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 Have you seen my screen? Please just post a plus. Please give me a plus if you have seen my screen. Thank you. Okay, let's see. So here you can see that I have the main Terraform file, and on the right side I have AWS console that allows us to see how our infrastructure will be deployed on this on the AWS cloud. And according to the our task, we have to create EC2 instance, and all configurations are shown here. You can see that we have the code that just describe what we want to have at the end of our deployment. Here you can see the provider. Provider is the AWS. I want to, and I have the access keys to connect to the AWS and deploy my infrastructure into the AWS provider. Also, I have several variables. For example, different variables, for example, subnet block, available zones, my IP address, instance type, and etc. All of these variables I have defined in the Terraform TF-vars file. I don't need to hard code all of my variables here, and I just this is the good approach, the best one of the best practices to do not share your keys and secrets on the main file. Just use variables. What else we can see here? So according to the task, we have to have port 22 must be open, and here you can see the rule that we use to open our port 22. This is a if you know, this is an SSH port. The next one, next rule, we have to define egress traffic. So we have to allow that any outgoing traffic should be allowed. And this rule is describe how can we do this. What else? We have to use the latest Ubuntu image. And what we have to use, so outputs here, you can see the outputs. The outputs after applying the Terraform files, we will see the public IP address, which we can test afterwards. And also we will see the which Ubuntu ID image we're using in our deployment. So here in this code, I just describe which subnet, which image ID I want to be deployed on my infrastructure, which availability zones will be used, and etc. So let's try to do something with our code. So the first thing that we need to do is the Terraform. Sorry. My computer is a little bit slow. I need to initialize the Terraform. We initializing backend. So we, generally speaking, we creating the state file, which will use to track all of the changes that we will have to deploy to our infrastructure. So it took a little bit. Let's wait. So if you have any questions, you can type into the chat, and I'll try to do my best to answer these questions. Okay, we will see that Terraform has been successfully initialized, and I want to see what I have to which deployment I will have at the end of the applying of my code. So for that, I'm using the next command, Terraform plan, and here we can see what will be deployed on our AWS cloud. It will take time. So it has been started. Okay, let's see. As I said before, as I mentioned before, Terraform is very smart infrastructure as code tool. So here we can see just the describing what we want to have after applying this code on the cloud. Just I said that I want to have a specific VPC. I want to have specific CIDR block, availability zone. I want to have that CIDR block consist of 000 route, specific route, and etc. etc. However, Terraform it's smart enough, and under the hood, it creates all necessary other necessary infrastructure under the hood. We doesn't need to define, for example, we can define, for example, CPU core or other infrastructure, but Terraform can take it into account and create by itself under the hood. For example, you can see that CPU options, it will be all automatically applied and will be known after apply. So EBS block devices, maintains options, metadata, network interfaces, and etc. All of this necessary configuration will be done by Terraform itself. Okay, we will see that we will have deployed our infrastructure at the availability zone US East 1A. We have the CIDR block 10.0.1.0.22, and from where Terraform will take this information. You can see that here I have defined all of the variables. For example, subnet CIDR block. I defined it here. But CIDR block is defined on Terraform somehow knows which CIDR block I want to use. All of this information are I have created here. This is a T2 micro. This is my IP address. This is my CIDR block that I want to use, and this access keys and secret key which I used. So let's go and apply our configuration. For applying this configuration, I use next command. Terraform apply. Sorry. And let's see what will happen under the hood on the cloud. Now it will ask us, do we actually want to apply our configuration on the cloud? It will take some time. Okay, let's wait. Okay. Yeah, you can see that all of these configurations will be applied, and Terraform asks us, will we accept all of this configuration? And if yes, just type yes. Okay. It will starting created all configuration, VPC, subnets, routes, security groups. Yeah, and you can see that our instance now on the pending state. I just need to refresh all of this. Still creating. Run. We have running instance here on our cloud provider. And you see that I here in the infrastructure on in my code, sorry, I have the outputs, and I set to Terraform to uh, to show the output on the screen. Here you can see two outputs. For example, AWS ID, AMI ID, which will be used on our EC2 instance, and the second one. This is a an IP address of our instance. Let's check. So you can see that we have the same public IP address, and we have other configuration of our EC2 instance. Now let's see the second option, the second option that we want to have on our EC2 instance, that there must be the incoming access to TCP IP to TCP port 22. So do we actually have this access? Let's check our security rule. So we have the security groups here, and we have inbound rules. And if we click on the inbound rule, you can see that, yes, I have the port range from the security group to the security group, and I have an access of inbound rule from my current IP address. Okay, let's see what other rules must we have. We must have any other. You can see here I have defined the second rule, that we must have the egress rule to all outbound traffic. And let's check if we have this rule. To check this rule, we just click to outbound rules and see if we have the this kind of rule. Yes, you can see that we have all port range to have outbound rule to the any outgoing access. Okay, let's check. Do we actually have the access to the port 2022? And for that, I'm using the nmap tool, and just want to copy paste my IP address. Yep, we will see that one IP address, one host scanned, and it's scanned that we have EC2, compute one. This is a DNS name of our EC2. And we can see that our instance is running. And we can do another check. For example, we may just try to ping our device. According to our rule, we do not have to ping because this rule, we didn't define this rule. Okay. And as you can see, we cannot ping our EC2 instance. And if we want to ping it, we just need to change our security rule groups. And we just need to give it inbound, edit inbound as inbound rule. For example, we want to use all ICMP from anywhere or from any source. Just save this rule and let's try it to ping. Yeah, you can see that our ping is working for now. So what else I wanted to show you? So I said that Terraform keep tracking all of our configuration, and it creates a Terraform state file. And you can see that all of this current configuration is kept in this Terraform state file. You can see that we have in this state we have EC2 public IP address, for example, this one. It has the latest Ubuntu image. All of this configuration, Terraform keeps in this file, Terraform state file. And if we make some changes into this file, for example, I want to create another instance. Just uncomment this code. I want to create another instance. I just want to save this and try to do Terraform plan. Let's see what will happen. So guys, if you have any questions, just put it into the chat. You can see that Terraform tried to refresh the state. What does it mean? It checks the current state and what we changed into our file. And it says that after the plan, he wants to add one object, and one object have to be changed. Which object we will see now. So he wants to add a new instance, and he will delete this block and will recreate another one. So if you remember, I told that Terraform has several concepts that will help to um, easily maintain our infrastructure. And these concepts called the idempotency that we will ensure that our infrastructure remains always remains consistent. And second one, immutability. And yeah, it says that we will replace rather than we will replace and recreate the same one, the same object, rather than change it. And it is a very helpful approach to maintain our infrastructure um, as we need. So okay, let's apply our code. Perform not plan, perform apply. Okay, instances. Let's see what will happen. Here we have to have another instance that I want to deploy on our AWS cloud. Okay. It will refreshing the state, and it always asks me if I want to apply my changes. Okay, let's see. Let's see. Creating. Yeah. Here we have two EC2 instances with the same public IP address. You can see this one and this one. So apply complete resources, one edit, one change. Let's see our Terraform state file. And here we have to see, you can see two instances that our Terraform state file now has. This one is the Ubuntu, and second one Ubuntu 1. And EC2 public IP and EC2 public IP 1. Resources that created. Our state file always keep track, as I mentioned before, keep track all the changes that we have on our deployment. So that's all for the demo. And If you have questions, please don't hesitate yourself and ask. Um, and ask questions if you have. So I'm stopping sharing the screen. And if you have, guys, any question, please ask. Okay, here is the good question. Is the Terraform account somehow paid? Um, do you know that Terraform have been free for several years, and for now, the HashiCorp, the owner of Terraform, currently they changed their license for using Terraform, and this license, it no one knows how this license will work in the future, but HashiCorp trying to say that it will not affect any old Terraform versions. But for new one, you have to purchase the license for if you want to use it on your infrastructure. And currently, I just try to find. Give me a second, please. Currently, they Terraform community created a just recently created used the Terraform's code and created open source infrastructure as code tool called OpenTofu. And I tried to share. I just post this link into the chat. And OpenTofu has all benefits from Terraform, and it you can, if you want to use, you can try Terraform and OpenTofu as well. They are similar kind of tools. If you have other questions, please don't hesitate yourself, guys. Ask. I will try to try to answer. Okay. Let me share the screen. So, best practices for implementing infrastructure as code. Here you can see that we have the reusable code, version control, always use modules. We can apply infrastructure testing, try to apply continuous integration and deployment, and store your state file, Terraform TF state file, which I showed you. Try to store it remote because sorry, um, because this allows you to when you using your infrastructure as code, state locking essential for preventing conflicts. For example, when you have several team members on your team, which currently working with the infrastructure, it prevents when other people or processes attempt to modify the infrastructure currently. And if, for example, if I want to modify my infrastructure, remotely keeping remote my Terraform TF states files allows to lock this file only for me. No one else can modify it. When I finish modifying my infrastructure, it will be unlocked, and another person then can modify and implement other configuration. So this is very important to store state your file remotely. And second, why we need to store the file remotely, because it serves as a backup and allows for easy restoration for our infrastructure. And next one is the remote state storage on AWS, for example, like S3 allows you implement access control and security. Who can access to your state file, for example? So, okay, if you have questions, please, I am open. Here at the next slide, you can see which tutorials you can use to try infrastructure as code. And I'm trying to collect in this slide the links to the different workshops, to the different cloud providers. For example, here you can see that AWS for workshop on you can that you can use to deploy your infrastructure on the AWS or Azure infrastructure or cloud providers. And here, this I think this is one of the excellent free tutorial which can be used to study the infrastructure as code, like free code camp. So, guys, thank you very much that you have been with me today. Please, you can share your thoughts in the um chat. If you have any further questions, please have a good rest of day. See you later. Bye.